Here are the video solutions to the homework that is due on Monday the 9th. So the directions were to solve and find the 6 trigonometric functions for the given triangle. So what we're going to do here is we're going to set up, and we want to find the sine of theta, the cosine of theta, tangent of theta, and then all of their reciprocal functions. So cosecant, the abbreviation for cosecant of theta, secant theta, and cotangent theta. Now, with the given function, with the given triangle, with theta located in the upper left-hand corner, we have the opposite and the adjacent. So opposite and adjacent is tangent, so 24 over 10. Now remember, that can be reduced, and we would like you to reduce it. And so 2 goes into 24 12 times, 2 goes into 10 5 times, so our final answer for tangent of theta is 12/5. Well, given that we have the tangent of theta, its reciprocal function, cotangent theta, we can rewrite as just 5 over 12. So we got 2 out of the 6 out of the way. In order to get the other 4 trig functions, we need to know the hypotenuse. And unfortunately, the hypotenuse isn't given, but we can solve for it using the Pythagorean theorem. So 10 squared plus 24 squared equals your hypotenuse, or c squared. We'll just call it h squared. So 100 plus 576 equals h squared. So 676 equals h squared. And if you take the square root of both sides, your h value, or hypotenuse, is 26. So we know now that h is 26. Using that, we're going to solve for sine. So sine is opposite over hypotenuse, or 24 over 26. That will reduce to 12 over 13. And because we know that the sine of theta is 12 over 13, its reciprocal function is 13 over 12. For cosine, it's adjacent over hypotenuse, or in this case 10 over 26. If we reduce that, we will get 5 over 13. And therefore the secant will be the reciprocal, which is 13 over 5. The directions for number 7 are the same directions for number 3. Find the 6 trigonometric functions. So let's go ahead, let's start with those. So we're looking for sine of theta, cosine theta, tangent theta, and cosecant theta, secant theta, and cotangent theta. So once again, we're given, in relationship to theta, the hypotenuse and the adjacent side, and the trig functions that involve adjacent and hypotenuse are cosine and secant. So cosine is going to be adjacent over hypotenuse, and secant is the reciprocal of that, so 14 over 9. We need to figure out the third side, the missing leg, and I'm just going to call this a. And once again, we're doing a squared plus b squared equals c squared. So a squared plus 81 equals 196. Subtract 81 from both sides, you get a squared equals 115. Now, when you take the square root, you should notice that there is no perfect radical of 115. In fact, 115 is divisible by 5 and 23, and both those numbers are prime. So we're going to just leave it as a square root of 115. So a is equal to the square root of 115, and we can now use that value to find the other trig functions. So sine is opposite over hypotenuse, and the opposite is radical 115 over 14. If we take a look at cosecant, cosecant is reciprocal of that, so 14 over the square root of 115. Now remember, you can never, ever, ever have a radical in the denominator, so we're going to multiply both top and bottom by square root of 115. And as the final answer for that value, you'll get 14 root 115 over 115, and that's going to be your answer for cosecant. Let's go ahead and take a look at tangent of theta. Cotangent is opposite over adjacent, or radical 115 over 9. Cotangent's the reciprocal of that, so we'll just flip it, 9 over radical 115. Same thing here. You can't have a radical in denominator, so I'll multiply both top and bottom by the radical. And what we'll have here is 9 times the square root of 115 over 115.